Okay, let's look at, let's do a little statistics here, comparing two samples, and we'll compare dependent versus independent samples. So we've got two samples and we want to compare their averages. And we had questions about what's the difference between two dependent samples versus two independent samples. So here I made up an example. We want to see if Raley's is cheaper than Safeway, okay? So one way to do it is to go into Raley's and Safeway and buy the exact same item from each store. So here, you know, item A was $2.90 at Raley's and $3 at Safeway. Item B is $4.50 at Raley's and $4.50 at Safeway. Item C, $3.30 at one place and $3.20 the other. So that's one way to do it. And those two samples are dependent because these two numbers go together. That $2.90 goes with that $3 because it's the same item. So if you have two samples and you can match the data up, every data point in one sample is matched with another data point in the other sample, and there's none that aren't matched like that, then the samples are called dependent. And to do that, we just make up a D column and we do a test, a single sample test on the D column. So let's do that for this problem right here. Now the other way, let me talk about the other way and then I'll come back and finish this problem. The other way, we have two independent samples. So we go into Raley's, we buy a whole bunch of stuff. We go into Safeway, we buy a whole bunch of stuff. But they're not the same items. So they don't match up. So this number doesn't go with that number. That number does not go with that number. You know, it's just a bunch of random stuff. So if the numbers are not specifically matched together because of the same item or the same person, then the two samples are independent. And you're going to do, you know, a different test. Okay. So for independent, you're going to say, well, is the average for Raley's, we think it's cheaper, so it'll be less than the average for Safeway, right? Cheaper means the average of Raley's is smaller than the average at Safeway. That's what cheaper means. So we could bring this over here and we could make it mu Raley's minus mu Safeway is less than 0. Because that does not have an equals in it, this is going to be our hypothesis. There's no equals in it. It's got to be the alternate hypothesis, right? Rule number 1. The null has to have an equal. So if it doesn't have an equals, it's got to be the alternate hypothesis. Therefore, the null hypothesis is going to be mu Raley's minus mu Safeway is greater than or equal to 0. So those are our two hypotheses right there. And we still have to follow rule 1, which is the null has to have an equals in it. Okay, so two independent samples, you're going to have a test that looks something like this. You're going to have two different mu's because you can't match them up. So you have two different mu's and, you know, less than or greater than or not equal to 0. Okay, so that's how we're going to start the independent. And right away, I'll write my conclusion while I'm thinking about it. I'm going to take the alternate hypothesis. I'm going to come down here and write my conclusion, which is we can or cannot be 90% confident. I said it was going to be a 90% test. Move this up a little. That 90% confident that Raley's is cheaper. Then you could put in there than Safeway. Okay, so that would be our conclusion based on the alternate hypothesis. Now over here, if we have two dependent samples, remember dependent samples, every number is matched with another number in the other sample by the item, by the same item or the same person or something the same in the two samples. Then you've got two dependent samples, and let me show you how you do that test. We're still going to say Raley's is going to be less than Safeway. Cheaper means less than. And then I'm going to bring this over. So I'm going to go Raley's minus Safeway less than 0. But because they're dependent samples, I'm going to say, you know what? I'm going to call Raley's minus Safeway because I can subtract them right here and make a D column. I'm going to call that Raley's minus Safeway. I'm going to call that the D column. And you have to have a population parameter in here. So we're going to say the average of the D column is going to be less than 0. So if they're dependent, you can make a D column, subtract every one of these, and that'll be your difference column. And then your hypothesis is going to be something about the average of that D column. Okay? So that does not have an equals in it, therefore it has to be the alternate hypothesis. So the alternate hypothesis is going to be the mu of the D's has to be less than 0. The null then must be the mu of the D's has got to be greater than or equal to 0. Okay? So two dependent samples, you're just going to have one mu. Two independent samples, you're going to have two different mu's. And you have to write it that way, or other statisticians are not going to know what you're talking about or what you're doing. So you have to pay attention and write those hypotheses correctly if you're going to get credit. All right, so let's do this. Well, let me write my conclusion right away. I can do that still. We can or cannot be 90% confident. And so we can or cannot be 90% confident that Raley's is cheaper. So we're still saying than Safeway. Okay? So it's our same conclusion. That doesn't change. All right, now let's do the test. So we did step 1, we did step 4. If you want, we can do step 2 next. So here's step 2. It's going to be a left-tailed test because the alternate hypothesis inequality is pointing to the left. And it's 90% confident, so 90% over here. So it must be 10% in the tail. It's a t distribution. We don't have population standard deviation given anywhere in the problem, so it's going to be a t. So therefore, we need degrees of freedom. And degrees of freedom is n of the d's minus 1. So that's going to be 1, 2, 3, 4, 5 minus 1 equals 4. So 4 degrees of freedom, 0.10 in the left tail. Let me see if I have a t-table here somewhere. Oh boy, I'm very unprepared. So critical T, 10% and 4 degrees of freedom is going to be 1.533. And you have to know to make it negative because it's in the left tail. So that's a little trick sometimes people forget. Left-tailed test has got to be negative, always, always, always. So 1.533 will be the critical T, 10% in the tail. Okay, that's step 2. Step 3 is find our data's T. So we're going to do that by looking at the D column. So we said D was going to be Raley's minus Safeway. Make sure you do it in that order. That's how we set this up. Raley's minus Safeway. So I'm going to do Raley's minus 2.9 minus 3 is going to be negative 0.10. 450 minus 450, that's easy, that's 0. 330 minus 320 is going to be positive 10. Here's $1.80 minus $2.20 is going to be negative 40 cents. And $1 and $1.05 is going to be negative 0.05. So that's our D column. So now to find our data's T, we use the formula D bar minus mu of the D's times the square root of the n of the D's over the standard deviation of the D's. So we got to put these numbers into our calculator and figure out D bar and the standard deviation of the D's. The mu of the D's comes from right here. We're assuming that there's no difference, so that's going to be 0. Let me put these numbers in and get a so find out what D bar is. So negative 0.1, 0, 0.1, negative 0.4, and negative 0.05. So let's see what the average of the D's is negative 0.09. and mu, right, like I said, is 0. And it's the square root of 5. The number of d's is 5. And I'm going to divide by the standard deviation, which is 1.188. 0.188. Okay? So 0.09 times the square root of 5 divided by that sample standard deviation. And that gets me a t-value of 1.07, and it'll be negative 1.07. Okay? So 1.07 is going to go over here. That's in the cannot region. So we cannot be, based on our small sample of 5 things that we bought, we cannot be 90% confident Raley's is cheaper than Safeway. So that's 2 dependent samples. Okay, we make it into one sample, the D column, and our test and all our hypotheses are about that D column if they're 2 dependent samples. Okay, let's see what happens if we have 2 independent samples. So same idea. Our hypothesis is going to be different. You know, it's got 2 different mu's in it. Okay, and we've got 2 samples, but because they're not matched or paired, we do not make a D column. We find out the individual averages for each column. Okay, so you have to put each column separately into your calculator and figure out the average for both columns. So let me do that. 4, 5, 3, 2.5, 1.5, 720, and 3, 2, 1. So the average for the Raley's column is going to be 3.2444. And I'm going to put that in memory. Standard deviation for the Raley's column is 1.92. I'll put that in memory also. And the N, how many Raley's items did we buy? 1, 2, 3, 4, 5, 6, 7, 8, 9. So N for Raley's is 9. Now you do the same thing over here for the Safeway column. So I'm going to get rid of all the data that I put in there. And I'm going to do the same thing for Safeway. So 2, 3, 6, 7.5, 4, 6, 4, 5, 3. The average for Safeway is 435, and the standard deviation for Safeway was 1.73, and there were 10 items there. So, you know, because the data doesn't have to match, there can be different numbers in both data sets. So there were in this case. So 9 in this column, 10 in this column. All right, now let's do the let's do step 2. Step 2 is it's going to be a t-table. Again, we were not given any population standard deviation. It's still a left-tailed test. So 90% in the middle and 10% in the tail. Degrees of freedom here is a little bit different. You look on your formula sheet, it's the smaller of n1 minus 1 and n2 minus 1. So smaller is going to be 9 minus 1, which would be 8. So 8 degrees of freedom. You got to remember that. It's a little weird. There's 2 samples. So, you know, you could have 2 different degrees of freedom. We use the smaller one. Always, always. So 10% in the tail and 8 degrees of freedom. So now I get 1.397 negative. Again, you have to remember to make it negative if it's a left-tailed test. All right, our data is T. This is step 3 now. It's going to be a big complicated formula. It's x bar 1 minus x bar 2 minus mu 1 minus mu 2 over S1 squared over N1 plus S2 squared over N2. So this is second formula down on your chapter 8 formula sheet. And you have to remember when you're doing this, if we did Raley's minus Safeway up here, we have to do Raley's minus Safeway when we put the numbers into this formula. So Raley's minus Safeway in your hypotheses, right, means you have to do Raley's minus Safeway in your formula. Very important idea. So let's do that. So I have 3.244 minus 4.35. We're assuming that there's no difference. That's from the null hypothesis, that there's not a difference in the averages. So it's going to be minus 0. We're dividing by the square root of the samples, standard deviation squared. It's going to be 1.92 squared over 9 plus 1.73 squared over 10, and then take the square root of that. So that denominator is tricky. Let me see if I can do that. So this was stored. Recall y is 1.92. I'm going to square it and divide by 9 plus the other standard deviation squared and divided by 10. Then that turns out to be 0.711. I'm going to take the square root of that, and I'm going to put that answer in memory. And that turns out to be 0.84. So our denominator here is going to be 0.843. The numerator, let's figure out what that is now, and I put that in y. The numerator is going to be, recall that 3.2444 minus 4.35. So that's negative 1.10. And then I'm going to divide that by this, 0.843, and I get negative 1.31. Okay, so that's step 3. That's our t. And now we compare that. We take that 1.31 and we take it up here and we compare it to the 1.39, and it just barely misses, right? It just barely. So 1.39 is over here, 1.31 is just a little bit that way from it. Right, here's 1.31, here's 1.39. So again, we're in the cannot region. So we cannot be 90% confident that Raley's is cheaper than Safeway. And if it's cannot, it's a possible type 2 error. You don't know type 2 errors. The probability of those are unknown. All right, so I hope that helps. And email me or ask me questions if you have questions on it, and we can do more if you'd like.